Okay, so right now what I'm doing is I'm testing the MEMS-like relay. So what I mean by MEMS-like is this is a electromagnetic relay that's behaving like an electrostatic because I am isolating the coil. Anyways, the purple line there is the regulation on the capacitor that I have. The blue is the incoming line, and the yellow line you can ignore. The green is the reference line. So right now I am holding these two buttons down, and those are connected to this power supply, which is floating with the 7.5 volts across it. Now when I release it, it's already charged the cap, so those are isolated. And it holds it pretty well, except after a while it'll start to drift. But what I would like to look at now is I'm going to move around this supply voltage. You see the blue line as I'm dropping it? It's still regulating around the green line, which is good. And as I'm getting closer to the purple, eventually it'll die out. Almost there. It's still regulating. Now it's not. So the blue line, which you can't really see right now, the blue line is over the purple line. So we're no longer regulating. What we're doing is the relay is always on, and we're just following the incoming voltage. So let me put that up again. Let's get our regulation going again. So right now, oops, probably need to recharge the cap. Let's see. Yeah, okay, so I lost some of my charge on my cap, so my voltage has to go a lot higher. So that's something, this capacitor here, I'm going to have to eventually make it where I can measure the voltage across it. Right now I don't have it set up to do that, so that's why I left this guy off, because I don't want to be accidentally draining the capacitor. So anyways, so that's that. It's getting ripple. So basically this is the supply that's this is the voltage source. This guy is actually doing nothing. This is the floating supply that's basically providing a voltage that's going down to this capacitor. These two switches here basically allow the capacitor to charge up, and then when I release it, it's naturally floating. This right here, this resistor, is right now it's set about 1 mega ohm. So if I decrease the resistance, well, I'll just decrease it a little bit. You should start to see the period starting to shrink. I'm going to fresh the cap up a little bit. So I just freshen the cap. I'm still decreasing the resistor. Still decreasing the resistor. Now we're starting to see a lot of change. I'm still decreasing the resistor. This is the load across the capacitor. And still decreasing the resistor. I'm still getting some regulation. This is really, really cool. So it's right now it's really, really fastly regulating. At some point the load's going to be too small and it'll flatline. And there we go. So now the load is too small and it's flatlining. And I will go back to the normal regulation. So once again, to recap, so what I'm doing here, this resistor right here is between the source and drain. So this is to recreate the resistance that's seen in a MEMS relay. This guy has very little resistance, so I'm basically matching the resistance in the MEMS relay. This op amp and that op amp are being used to basically, these guys are basically unity gain buffers that are following the gate and bulk inputs. So basically, we see basically almost no current draw. These are 741, so they have a very tiny current draw, but it's very, very tiny. And then I have resistors here that are being used to set the pull-in and release voltage. This guy is a reed relay. Technically it's supposed to be 12 volts, but I got him triggering at a lot lower voltage, so yeah, it's lying. I mean, I got it activating around 4 volts, which is really weird. And the other reed relay, which was supposed to be 12 volts, it's labeled right here that it's 12, that one was also triggering around 4 volts, which is quite strange. But I'm not using the clock. Well, I am. I'm using the clock to trigger this guy for no reason at all. And there you go. Basic regulation. So now I know this setup works. So what I'll do when I get into test the MIMS device is all I have to do is I have everything color coded. So green is for gate, blue is for bulk, orange is for drain, yellow is for source, and basically all I have to do is pull out these 4 wires, put those 4 for the initial testing to make sure it works. And now that I know this circuit works, I can plug that up as well. I'm using a Zener right here to set the bulk for the regulation. This is set at around 4.9 volts when the source is 7 volts. So yeah, and it doesn't feel hot, which is good. None of those parts feel hot, so that's good. So, okay, that's my current setup.